Well, this semester has been going on, and you probably are running out of gas. So, what better time to inject, yes, another one of Dr. Cho's superior humorous jokes. What is this? That's right, it's low tide! And what is this? High tide! That's correct. And what is this? The tide is turning! And yes, now the tide's gone out. Today we'll be talking about big data because so much of marketing is about data. So it just kind of makes sense that you kind of have a feel for what this is all about and what are the things that people look at. Uh, the thing is, it's a topic where you could spend hours and hours of talking about. I just want to give you a flavor to know what's available to you. The thing is, we live in the age of data. I mean, because of digital devices, it's so easy to create data. And what it's about is what we call the 5 V's. And I'll be discussing that. That essentially care about velocity, variety, veracity, volume. And all of a sudden I've got a brain hiccup and I can't remember the 5th V. Uh, see, volume, anyway. But ultimately what it comes down to is that these data analytical tools are tools. It comes down to your creativity in interpreting what the data means and seeing what it is you can do with it. Now when they talk about megabits or gigabits and things like that, this gives you an idea of how big a volume we're really talking about. And to kind of put it into perspective, right now in 2 days, we create more data than was created since the beginning of mankind to 2003. And this is kind of like paper usage, meaning when printers came out, everybody said, oh, we're now living in the time of electronics, it's the age of paperless, paper's going to run out. Well, actually paper did run out. And paper ran out for the simple reason that we've never been able to create usage of paper so much before. And that's what people didn't take into consideration. What ended up happening is before, like, my undergraduate thesis was 25 pages long, and it was typed on a typewriter. And my graphics, we used something called a flexi curve, which was basically this strip of plastic that you bend it around, and so when you put down you hand measured your data points, and then you put this flexi curve around and you kind of sketched it. The thing is, how much paper can I really create in terms of usage? But the same thing goes with data now, because we have so many digital devices, and you always have a digital device pretty much on you all the time, or at least within arm's reach. It's so easy to create data. And that's why today we pretty much create petabytes every day. Now the thing is, when we think about data, essentially man is a thinking being. And fundamentally, we look for patterns. This is why we can create data, because what is data? It's just a bunch of patterns that we create. The thing is, without our intelligence, let's face it, man is a pretty feeble animal. I mean, seriously, you take away all our technology, and what are we? You know, if I'm a lion in the Serengeti, I'm thinking, wow, I could go after that gazelle that can run 40, 45 miles an hour, or I could go after a fatso human who's only moving 25 miles an hour, who doesn't have horns and doesn't have hooves. One thing I joked about is once I had a quiz and I took away calculators, and most of the class got it wrong. And basically they could have multiplied 250 times 100. I mean, so many people were getting it wrong, I had to pull out a calculator and say, am I right? But anyway, the thing is, how did all this data started? It started with a couple of Frenchmen, Pascal and de Fermat, who basically just wanted to notice that in gambling there were patterns, so they invented a math system so they could win at gambling. You're probably familiar with Ronald Fisher. He's the one who created ANOVA, which created the current standard in manufacturing and quality. And it's by the time we get into the time of the PC, where all of a sudden now we have data analytics as a daily part of our lives. And Google was actually the one who came up with the term data analytics. And they did that for the analysis of your website and everything else. And so now we've created an entire age of it. At MIT, we used to laugh at the math majors. We used to joke that if you got a B in vector calculus, you became a math major, because everybody else who got A's pretty much went on to electrical engineering or aeroastro or something like that. And now the math majors have gotten the last laugh on Wall Street. They're being hired up left and right. Because everybody, I mean, let's face it, the financial guys who could do the typical analytics, the guys who go to business school, they're a dime a dozen. But the thing is, to find a really good math guy or whatever, my brother laughs at me because I pretty much have gone the educational route and all. And he got his master's degree in computer science. After he got his master's degree, he said, screw it. I just want to make money. So he went to Wall Street in computer science. The thing is, when you look at marketing, a lot of what drives marketing is data. I mean, no matter what part of marketing you talk about, data is involved. And so that's why it impacts every aspect. The thing is, traditionally, we think of data as just being the domain of geeks. But because of the home computer, and because of your phone and everything else, all those barriers have been broken down. So what it comes down to is how you want to go about using it. The thing is, the people who have adopted data-driven marketing, and not only that, but data analysis thinking, instead of saying, well, it's my gut feeling it's this or something like that, those are the people who are winning. A lot of you are probably familiar with Moneyball, how the Oakland A's basically found economic inefficiencies and came up with their own statistical metrics. Now everybody has pretty much adopted it. That's the problem. You come up with something new, somebody's going to copy it. John Henry, who owns the Red Sox and is a billionaire, when he started his financial firm, what it was all based on? Math. He basically went out and found the best predictive analytics guys, and he hired them into a finance firm, and now he's a multi-billionaire. Dell Computer. Michael Dell. Well, first of all, this wasn't an ordinary kid. I mean, his parents were like bankers and lawyers and stuff like that, and so his family dinners at night were about, what do you think the impact of a change in the prime is going to be? I don't know about all of you, but my dinner conversations, it's like, how was lunch today? But anyway, Michael Dell, first and foremost, has always been an analytical marketer. When he had a paper route, what he did is he noticed a whole bunch of different homes and all. He started writing down all the data about who lived somewhere, how many people do they have, how long have they been living there, how much houses are selling in the neighborhood. He would collect all that data and he would sell them to local companies. And that's how he got to start making money. And subsequently, Dell, people think Dell was always about, well, you buy your computer online and get to pick your pieces. No, Dell actually started before the age of the internet. And what Dell did is he would have a promotion. And he would have a promotion with 6 different promotions with 6 different phone numbers. And what he would do is, okay, which promotion is getting us the most sales? And those are the promotions that he would pick. So this kind of thinking has been around for a while. Now, what are the things that people use math for? We use it for prediction. We use it for discovery. Looking at data, can I find things that I didn't know existed before? We use data for control. We like to keep things with a certain bounds. We use it for maintenance, to use find fault repairs. We use it for modeling. And that's that, okay, we don't want to go out there and talk to 1,000 people, or in terms of building an aircraft, well, can we model this first and get an idea what's going to be an issue before we actually do it? And so what it does is it saves you a ton of money because you find out what the issues are and you don't actually have to do it. And finally, we use it for validation and verification. And just to let you, to repeat it again, what validation is saying, does this work? How much data or evidence do I have to pull together to make you believe that this works? And verification is, okay, that's a great trick, but can you do it more than once? And when you can do it once with consistency, that's considered to be verification. In terms of what functions this all provides in terms of data is mining means we're extracting good data. So we use statistics. We use querying, meaning I got this big amount of data. I have to be able to put in queries to figure out what it is that I want. Basically, yeah, it's like Google. Ask. Warehousing, where are you going to put all this stuff? Regression is about predicting values. And KDD, which is knowledge discovery and data mining. That's where you're starting to talk about AI. That's where you have the artificial intelligence. Go in, you put in rules for it. Or you tell it, look, I'm looking for this specific pattern. Anytime it comes up, go ahead and do this. And so you can actually have actions in real time. The thing that's kind of scary right now is Microsoft actually has some AI software. And what it does is it actually starts to rewrite part of the code to compensate for things happening. That's getting scary because now you have machines that can reshape themselves. Dun, 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 dun. But on the other hand, I'll be long dead when this comes into place and you're going to have to deal with it. Okay, so in terms of, okay, I got my numbers wrong. It's exabytes. I thought it was petabytes we created every day, which makes it even more impressive how much data we create. But what data revolves around, the metrics that we look at it is called the 5 V's. One is volume, velocity. How quickly can I employ that data? And how quickly can I create it? Variety. Variety is, well, you think of data as just, okay, they're just numbers. No. There's lots of different kind of data. What if the data I'm looking for is, like I have a company and I'm looking for likes and dislikes, or I'm looking for people, what they're saying about my company, to go out and flag it. That's one kind of data. Pictures is another kind of data. And pictures becomes really challenging. It becomes really challenging because what are pictures? Well, basically it's a bunch of pixels and numbers associated with it. And so that becomes very difficult for a data system to track. And that's why it's so important that you tag. By tagging, it can figure out much more quickly what's going on. Maybe we're just talking about numbers like the Internet of Things. What are sensor outputs? And so that's what variety is about. The other 2 V's, and these are starting to emerge as more important. Variability is the consistency of the data. That if I look at this twice, am I going to get the same thing both times? And veracity. And veracity is becoming more and more a big deal. Why? Because we live in the time of fake. And the thing is, there's so much like bot created data or something like that to throw us off. So how do you know what you're getting is real? And so not only that, but the truthfulness of the internet is really becoming a big issue for people. And so the thing is, okay, Dr. Cho went out to buy some money for Startup Village. I'm the advisor for it. Bought some brownies. Let's see. Oh, no, I went shopping for myself too. I got some Thomas English muffins. The thing is, if you look at just a receipt, look at the amount of information's in there. You see how much I purchased at Costco. Yeah, I know, it's amazing. Nobody goes into Costco and only purchases $23 worth of stuff. But anyway, where the purchase is, what time it was. From time, I can get what kind of season. How did I go about paying? Like, for example, what if this payment, oh, that's right, Costco only takes Visa. But if it was a different store, what if they were only taking American Express? What items I'm actually purchasing. The thing is, you can start to track my patterns. And once I can track your patterns, then you have predictability. And you are systematic. In terms of volume, Sears had a lot of personalized. This is really interesting, and what people don't know about it, Sears is actually one of the biggest big data integrators. Unfortunately, they have more fundamental problems than data. They just have, well, not to offend anybody, but I think their stores are kind of crappy. Okay, there I said it. I just said what everybody else was thinking. But anyway, Sears, the problem is all their stores weren't connected together. And so in terms of getting the data, it would take 8 weeks to get the data from their stores and find out if their promotions were working. 8 weeks, a season only lasts like 12 weeks. It's too late to do anything. And so what they did is there are technologies right now, commodity servers, which are cheap and can link a lot of places all together and centralize your data. This goes back to what I was talking about, that you want to query your data, you want to be able to access it, how you're going to warehouse it. And it's called a Hadoop cluster. And the way you can kind of think about it is in the early days of the internet, if you wanted a server, you had to buy a $10,000 machine. And then they found out through edge servers, you could connect a bunch of little servers together instead of having one monster one that you have to go to. And the Hadoop cluster is basically a software framework. And now there are other frameworks that also compete with it. But the basic idea is that because they were able to get rid of the bottlenecks, they were able to drop the promotion time down to 1 week instead of having to deal with that 8. And how did they do it? They outsourced to an integrator originally to do it. In terms of velocity, trying to figure out things in real time, they found out real-time real estate data outperformed the traditional models of data collection that realtors used. In terms of variety, the CDC actually thought, everybody tweets in real time. And so they actually did searches of tweets and found out that Twitter actually reported the spread of disease in terms of predicting flu trends. And so all of a sudden, instead of having those guys in white suits going out there taking samples, now we have an electronics means. The thing is, in terms of impact, when they went out and they asked companies, what's most important to you? The thing is, everybody has access to velocity. As long as you're willing to pay the money for the infrastructure, you have that. The volume of data, actually the problem isn't enough data. The problem is too much data. And the other problem with the volume of the data is some of it's good and some of it is noise and crap. So filtering that out is a challenge. But what it comes down to is where they're all competing on is variety. How can they think of new ways to find data? For example, polling for presidential candidates. The way they did the surveying is what they do. Are you going to vote for Hillary Clinton or are you going to vote for Donald Trump? The problem they found out is that a lot of people didn't want to answer the polls because there's such a negative backlash against President Trump that people were kind of embarrassed to say they backed him. As a matter of fact, I was talking with this one student, and he was a Trump backer, and he was proud of it. He had no problems saying that he was backing Trump, and he literally lost friendships over it. And so the thing is, a more accurate way of polling might have been to ask people, because they had very distinct values that they were backing. Like put in order what values are important to you. For example, women's equality pay, redistribution of wealth. Issues like that were distinctly Hillary Clinton. For Donald Trump, it's about immigration and border security and issues like that. And then through the values, you could actually figure out where people are more likely to vote. So that's a way of actually doing it in a different sense to develop variety. And so the thing is, in terms of variety, there's legacy sources, unstructured data, and of course social media is really important. There's a ton of data to mine there. I mean, I just am awe of Zuckerberg for putting this together because it's just a marketer's dream, all the information that you get off of Facebook. It's also incredibly easy to set up a promotion on Facebook. Anyway, I think at this point, this is a good place to take a break, and we'll go on to the next lecture.